Hello friends, myself Ramesh Chandra and I'm taking lecture number 7 on complex numbers. In this lecture, we will more learn about the problem solving ability of complex number that is very essential for competitive exam like JEE Main and Advanced. So let's learn how to solve problems and how to approach problems. So let's start. In this lecture, we will learn about the polynomials and complex numbers and the equations involved in complex number. So let's move on. First question. If one root of this is 4 minus 3i, then find the other. So as per the concept of quadratic equation, that is ax square plus bx plus c is equal to 0, if we have root alpha and beta, then as per the rule alpha plus beta, that is sum of the root is minus b upon a, and the product of root, that is alpha into beta, is c by a. So we will apply the same concept here. So let's say alpha is the other root. Alpha is the other root of this equation. So what we will have is alpha plus 4 minus 3 iota is equal to sum of the root is minus b upon a. So minus and minus is 7 plus 3 iota upon 1 plus iota. Now if we multiply denominator by 1 minus iota, that is conjugate of this, then we will get 1 minus iota, then we will get, that is 7 plus 3 iota and minus 7 iota and minus 3 iota square upon 2, 1 square plus 1 square. So you will get this as 7 and I square is minus 1, so 7 plus 3, that is 10, and 3i minus 7i, that is minus 4i upon 2, that is 5 minus 2i. So alpha plus 4 minus 3 iota is equal to 5 minus 2 iota. Hence alpha is equal to 5 minus 4 minus 2i plus 3i, and that is alpha is equal to 1 plus iota. So 1 plus iota is the another root. If we think of product of root, then we can check it out. Then product of root, that is 4 minus 3i, that is first root, and that is 1 plus iota, 1 plus iota, that is equal to, we multiply by 1, we will get 4 minus 3i, and I, if we multiply by I, we will get 4i minus 3i square. So this is gonna be equal to 3i square is minus 3, so minus minus plus 3, so this becomes 7 plus iota, and this is the product of the roots. Even if we say that alpha into, that is 1 plus I, the product of root alpha into beta, that is 6 plus 8i c upon a, that is 1 plus I, and if we multiply it by 1 minus I, 1 minus I in numerator and denominator both, and then we will get, this is 6 plus 8i, and that is minus 6i and minus 8i square upon 2. So what you are getting here is, this is 6 and plus 8, 14, and 8i minus 6i, that is 2i divided by 2. So you will again get 7 plus iota. So you can check it out. We are getting product of root as 7 plus iota. But in this case, our aim was not to get product, but find the other root. So 1 plus iota is the other root. Let's move on another problem. Solve the following equation over complex number C and express in a plus iota b form. We have first equation as I time x square minus 3x minus 2i equal to 0, and second one 2 times 1 plus I x square minus 4 times 2 minus I x minus 5 plus 3i equal to 0. Answer to the question is as shown here. For the first one, these are the two answers, and these are the answer for second one. So let's solve them one by one. This is the quadratic equation, so we can apply the formula of x equal to minus b plus minus under root d upon 2a. We can apply this formula. So first of all, we need to calculate the discriminant, that is b square minus 4ac, and in this case what we are getting, b is minus 3, so minus 3 whole square minus 4, a is I, and c is minus 2i, minus 2i, minus 2i. So this is 9 and plus 4i into 2i, that is 8i square, 8i square, and this become equal to 1. 9 minus 8, that is 1. So root of this equation are x is equal to minus b is minus 3 plus minus under root d, that is 1 upon 2a. A is I. So what we are getting here is 3 plus minus 1 upon 2i. If we take plus sign here, then we will get first root as 4 upon 2i, that is 2 upon I. If we multiply it by I in numerator denominator both, then I square become minus 1, so this become minus 2i. So first root is minus 2i. Now if we take minus sign here, then we will get another root x2, that is equal to 3 minus 1, that is 2 upon 2i, that is 1 upon I, and if we multiply both by I, then we will get minus I. So minus 2i and minus I are the answer to this question, are the root of this equation and the root of this equation. Even we can have different technique for solving this equation as well. So let's have another method for this question. If we multiply both sides by I, then we will get I square x square minus 3 iota x minus 2i square is equal to 0, and I square is minus, so minus x square minus 3ix plus 2 is equal to 0. If we again multiply by minus 1, so we will get x square plus 3 iota x and minus 2 is equal to 0. So you can factorize this as x square plus 2 iota x plus iota x and minus or plus we can have 2i square is equal to 0. If you think of this, then you will get x as common, then you will get x plus 2i, and here you will get I as common, then you will get x plus 2i is equal to 0. So you can see here as x plus I into x plus 2i is equal to 0. So x is equal to minus I and minus 2i are the root of this equation. So this is another method to solve this quadratic equation. Let's move on next equation. This is the equation. Let's find the discriminant of this, that is 16, 4 square 16, 2 minus iota whole square b square minus 4a, that is 2 1 plus I 4a into c, that is 5 plus 3i, 5 plus 3i minus, so this become plus. So this is 16 times 4 minus 1 minus 4i and plus 8 times 5 minus 3, that is 2, and 5i plus 3i, that is 8i. So this is become equal to 48 minus 64i, and here we will get 16 plus 64i. So you will get cancel these two and this become 64. So D is equal to 64. Discriminant of this quadratic equation 64. So root of this equations are alpha comma beta is equal to minus b, that is 4 times 2 minus I, and this is plus minus under root d. So under root d is equal to 8. So this is 8 upon 2a, that is 4 times 1 plus I. So root of these roots are alpha comma beta, and these are equal to, you can cancel 4 here and it become 2 minus iota plus minus 2 upon 1 plus I. So first root, let's say alpha is equal to, taking plus sign here, then it become 4 minus iota upon 1 plus iota. And let's say beta for negative sign here, then this become minus I upon 1 plus iota. So to express in the format of a plus iota b, so let's multiply it by 1 minus iota in numerator and denominator. So this become 4 minus iota into 1 minus iota upon 2. So alpha is equal to, that is 4 plus I square, that is 3 and this is minus I and minus 4i, so this is minus 5i upon 2. So you are getting first root as it here, and if we multiply 1 minus I in this, then we will get 1 minus I, then we will get beta is equal to minus I plus I square, that is minus I, and plus I square, that is minus 1 upon 2. So you can observe this is the another root for this question. So let's move on another problem. Problem number 3. Answer to this question is minus 77 plus 108i. If we directly put x as 2 plus 3i in this expression, then this question become very calculative. So to remove the calculation of this question, what we do is we take different strategy as x is equal to 2 plus 3 iota. So we will have x minus 2 is equal to 3i. If we take square both side, then what we are getting here, x square minus 4x plus 4 is equal to minus 9. So what are we getting here? X square minus 4x plus 13 equal to 0. Now if x is equal to 2 plus 3i, then we know that this expression become equal to 0 if we put x equal to 2 plus 3i. So what we do is we will express this expression with the help of this. So how to express the given expression with the help of this? We just divide this expression by this. So what we are having here? So let's divide it. X square minus 4x plus 13 divides x to the power 4 minus x cube plus x square plus 3x minus 5. So first of all, let's multiply it by x square, then we will get x to the power 4 minus 4x cube plus 13x square. If we subtract them, then this sign become, plus sign will become minus and minus sign become plus. So this will get cancel out. This become 3x to the power 3 and minus 12x square, and take plus 3x here. Now if we multiply it by 3x, then we will get 3x cube minus 12x square plus 39x, and again subtract them, minus plus minus. So this is 0 and again this is also 0. So this become minus 36x. Now take minus 5 as common. Now we can't divide this since its degree is less than this. So this is the remainder. So what does it mean? It means that x to the power 4 minus x to the power 3 plus x square plus 3x minus 5 can be written as x square minus 4x plus 13 into x square plus 3x plus remainder minus 36x minus 5. Minus 36x minus 5. Now, if we put x equal to 2 plus 3i in this, we put x equal to 2 plus 3i in this expression, then we already know about that this expression become equal to 0. So this whole expression become equal to 0 if we put x equal to 2 plus 3i. So what will remain? It will remain minus 36 times x, that is 2 plus 3i minus 5. 2 plus 3i minus 5. And if we solve this, then we will get minus 72 minus 5, that is minus 77. So this is minus 77, and 36 into 3, that is minus 108i. So this is minus 108i. So this is the answer for this question. Let's have another problem of similar kind. Answer to this question is minus 160. Again, if fx is this, then find f of minus 5 plus 4 iota. So what does it mean? If we place x is equal to minus 5 plus 4 iota, then we need to find the value of this expression. So let's solve this question. So let's say x is equal to minus 5 plus 4 iota. So we will have x plus 5 is equal to 4 iota. If we square both sides, then we will get x square plus 10x plus 25 is equal to minus 16, and hence it become x square plus 10x plus 41 is equal to 0. Now we know that if x is equal to minus 5 plus 4i, then this expression become equal to 0. Now we will use the value of this expression to find the value of this. So what we will do is we will just divide this expression by x square plus 10x plus 41. So x square plus 10x plus 41 divide x to the power 4 plus 9x cube plus 35x square minus x plus 4. So if we divide it by x square, then we will get x to the power 4 plus 10x cube plus 41x square. So on subtraction, this will get cancelled out, and here we get minus x cube and minus 6x square and minus x, take minus x here. So if we multiply it by minus x, we will get minus x cube and minus 10x square and minus 41x. Again plus plus plus. So this will get cancelled out. This become 4x square plus 40x and plus 4. So if we multiply it by 4, then we will get 4x square plus 40x and plus, that is 164. So this is minus minus minus. So you can observe here this is minus 160, and you are getting remainder as minus 160, and that is the answer to this question. if we put x equal to this in this expression, then the value of this expression will be minus 160. Let's move on another problem. Find all the root of the equation this z belongs to complex number. So answer to this question are as shown here. As you can see, we can have this equation as 3z minus 1 to the power 4 is equal to z minus 2 to the whole power 4, and this become 3z minus 1 upon z minus 2 to the whole power 4 is equal to 1. So this become the fourth root of unity. This become the fourth root of unity. So 3z minus 1 upon z minus 2 is equal to plus minus 1 and plus minus iota. So if we take first case, then we will get 3z minus 1 upon z minus 2 is equal to 1. Then we will get 3z minus 1 is equal to z minus 2, and this become 2z equal to minus 1. So z is equal to minus 1 by 2. So you will get first root as it here. Now if we take 3z minus 1 upon z minus 2 is equal to minus 1, then we will get 3z minus 1 is equal to minus z plus 2. So this becomes 4z is equal to 3. So z is equal to 3 by 4. So this is the another root. Similarly, if we put plus I or minus I here, then we will get other two roots. So this is the technique to solve this question. Let's move on another problem. If iota z cube plus z square minus z plus I equal to 0, then so that mod z is equal to 1. So to solve this equation, let's factorize the given equation, that is iota z cube plus z square minus z plus I is equal to 0. If you think about, that is iota z cube minus I square z square minus z plus I is equal to 0, and hence if we take iota z square as common in this case, then we will get, if we take common iota z square from this, you will get z minus iota, and if we take minus 1 as common at this place, then we get z minus iota is equal to 0. So this become z minus iota become factor of this, and iota z square minus 1 is also another factor of this equation. So what we are getting here, that is z is equal to I, or iota z square is equal to 1. So these are the two possibilities in this equation. Now if z is equal to I, then mod of z will be mod of I, that is equal to 1. Now if iota z square is 1, then mod of iota z square is equal to mod of 1, and this is mod of z square is equal to 1. So this implies mod of z is equal to 1, and mod of z is not equal to minus 1, as mod of z is positive quantity. Let's move on another problem. If one root of the equation z square plus a plus iota z plus b plus iota c equal to 0 be real, where a comma b belongs to real, then c square plus b minus ac is equal to. We need to find the value of this. So answer to this question is 0. If you wish, you can solve this your own. So let's solve this equation. As per the given question, one root of the equation be real. So let's say one root be alpha is equal to k, where k belongs to real number. Now if k is a root of this equation, then this will satisfy the given equation. This means, this implies k square plus a plus iota times k plus b plus iota c become equal to 0, where k is a real number. So let's separate the real part and imaginary part. So real part must be k square plus ak plus b, and plus iota times k plus c is equal to 0. So this is real part of this complex number, this is imaginary part, and this is equal to 0. So this imply k plus c is equal to 0. So k is equal to minus c. If we put k equal to minus c in this case, then we will get k square plus ak plus b equal to 0, and the whole complex number is equal to 0. So we are going to replace k by minus c. So what we are getting here, c square plus a times minus c plus b is equal to 0. So we are getting c square minus ac plus b is equal to 0, and it is asking for c square plus b minus ac equal to 0. Hence the value of this is 0. Let's move on another problem. Find z belongs to complex number for which z square plus 2z plus 2 is a positive real. So let's solve this question. As per the question, z square plus 2z plus 2 is a positive real number. So this should be greater than 0. This should be greater than 0, as this is a positive real number. So let z is equal to x plus iota y, where x comma y belongs to real. So if we put z equal to x plus iota y in this expression, then what we need to do is x plus iota y whole square plus 2 times x plus iota y plus 2 should be greater than 0. So if we separate the real part of this, we will get x square minus y square, and plus 2x and plus 2, that should be greater than 0, 1 in equation, and the imaginary part of this expression must be 0. So that is 2xy, that is imaginary part, plus 2y, that is also imaginary part, must be 0. Why we are doing this as equal to 0? Since in complex number like a plus b I greater than 0 happen only if b is equal to 0. We cannot compare like 3 plus 4 iota greater than 6 plus 7 iota. We can't compare that, but we can compare like 3 is less than 6. So to have this inequality, we must have imaginary part as 0. So take 2y as common. So x plus 1 is equal to 0. So we have two situations. Either y is equal to 0 or x plus 1 is equal to 0, that is x equal to minus 1. So these are the two situations. So let's solve first. If y is equal to 0, then what we are getting here? Then this is like x square. If we put y equal to 0 in this inequality, then we will get x square plus 2x plus 2 greater than 0, and this is x plus 1 whole square plus 1 greater than 0. So you can see this is true for all x belongs to real. Now if we have x equal to minus 1, so put x equal to minus 1 in this inequality, then we will get 1 minus y square minus 2 plus 2 greater than 0, and this become y square minus 1 less than 0. So this imply y belongs to minus 1 to 1. So solution of this is minus 1 to 1 if x equal to minus 1, and this is true for all x belongs to real if y equal to 0. So let's plot the solution of this question. So let's say this is x-axis, and this is y-axis. So you can see if y is 0, then this is true for all x belongs to real. So y is 0, y0 line is this. So this is the solution. This whole x-axis is the solution of this equation. And if x equal to -1, then y will lie in -1 to 1. So let's say this is 1 and this is -1. So this is also -1 here. So we will get solution from here to here. So you can see the whole real axis and the line and the point over this line segment is the solution of this equation. Thanks. If you wish, you can join our online lecture series. Write to us at info@mathsarc.com or call at 020 699 00 111.